So now we are going to discuss about uniform acceleration and retardation motion. The uniform acceleration and retardation motion is also known as parabolic motion, right? This uniform acceleration and retardation motion, the first half of the outstroke, say for example this is outstroke, and this outstroke we divide into two parts. This is first half and this is for second half, right? So this is uniform acceleration and uniform retardation, right? So the first half of outstroke is completed with uniform acceleration from A to D, right? And the remaining half of the stroke is with uniform retardation from D to G, right? Similarly, for return stroke, the first half of the return stroke is completed with uniform acceleration from H to L, and the second half, this is first half for return stroke and this is second half for return stroke, right? So first half completed with uniform acceleration from H to L, and the second half completed with uniform retardation from L to P, right? And this parabolic motion, as like SHM, already we discussed in our previous video. This uniform acceleration retardation is recommended for follower when the cam rotates at low and moderate speed, right? As like SHM, clear? And now let us solve a problem. How to construct the displacement diagram for uniform acceleration and retardation, and we have to follow the sequence already we discussed. The follower to move outward, which means 0 O, I mean theta O, outstroke, through 25 mm displacement, which is equal to 25 mm during 120 of cam rotation. First segment, which is 120, and next which is 60 degree as dwell, and the return stroke which is equal to theta R, which is equal to 90 degree, and remaining which is equal to dwell 90 degree. Okay, so 120, 60, 90, 90, add all those things, you will get 360 degree. Clear? So first 120 degree which is outstroke and 60 degree dwell, the next 90 degree return stroke, and remaining 90 degree which is dwell, right? So I am using software to explain this, right? So this is how we are going to draw. Anyway, let me explain in the software, right? This is outstroke and this is dwell, return stroke and dwell. And first outstroke which is 120 degree as we discussed in our previous slide according to the given data, and this is next 60 degree for dwell and 90 degree for return stroke and 90 degree for remaining last dwell, right? So first this is 25 mm displacement diagram height, right? First draw the horizontal line with 360 degree and divide this 120, 60, 90 and 90 for outstroke, dwell, return stroke and last dwell, right? And height which is equal to 25 mm, and complete this and take 120 degree first outstroke. Then we have to divide this outstroke into n number of equal parts. Say for example 6 or 8, 6 is the optimum value, right? So divide this first outstroke into 6 number of equal parts. This is segment 1, 2, 3, 4, 5 and 6, right? So after completing this division of 6 segments, select the middle one, right? So middle vertical line, draw the vertical lines for each divisions, right? After completing the division of this 120 degree, for say for example 120, which means 20 degree, say this is 20 degree, I mean here scale is 1 degree which is equal to 1 mm, so this is 20 mm, 20 mm, 20 mm, like 6 divisions are there, and join the vertical lines first, right? I mean draw the vertical lines and select the third vertical line, and again we have to divide this third vertical line into n number of equal parts, say 6, because already we divided 6 in the outstroke, so that we have to divide this vertical line into 6 parts, right? 0, 1, 2, 3, 4, 5 and 6, right? So A which is equal to 1, B which is equal to 2, C which is equal to 3 and D which is equal to 4, E which is equal to 5 and F which is equal to 6, right? And this is 0, right? 0 and 0, that is first point, and join 0 and 1, 0 and 2, 0 and diagonal, right? This is center point, leave it this, and from right side join D, G, E, G, right? So this is first inclined line, second inclined line, and third one is center point. This is fourth inclined line, and this is fifth inclined line. Clear? And see here, the line 1 intersects the line vertical line, which is first point, and the inclined line 2 cuts the vertical line, that is second point, right? So third point is the center line. Then fourth one, which is, see here, the D line, DG, which is the fourth one. The fourth line, it cuts the vertical line, fourth vertical line, at that point, which is called as E, right? And the fifth inclined line, it cuts the fifth vertical line at point F, right? So now point A, B, C, D, E, F, G, right? Trace all the point, right? And to obtain the parabolic displacement curve for outstroke. Do the same procedure for return stroke, right? Let me explain in the software how to draw or how to construct this displacement diagram. Okay, thank you.